Okay, what we're doing now is we have our multimeter. I have an SC77 hooked up, and what I'm reading is the flame rectification. We're reading 2.6 microamps. And you can see my setting. I'm on the microamp DC setting, and what I have is I have one lead connected up into the flame sensor. This is my flame sensor that's directly into the flame, and that comes down into my meter and comes in right here to my meter, and then the red wire is connected to the other lead. This is the lead that goes to the flame sensor. So now we just shut off. We'll bring it back on again, and you'll be able to see. Right now I'm reading 0 microamps. My connection came off. Put my connection back on. So I connect right up in here on where the sensor wire, where this lead went, this lead right here. So what's going to happen is the blue is going to be output from the flame module, sends out the signal. The signal then goes through the sensor and then in through the flame and back to the ground, back to the sensor, or back to the module. It's called flame rectification, so the flame completes the circuit. And what I've done is put my meter in series. It's an inline microamp DC meter is what I'm using. So I'm on the microamps DC, and the electrons are flowing through the meter. The meter's in series, plugged into where my probe plug. So I unplug this with my red lead, goes through my meter, out of my meter, into the sensor, to the wire, the lead that goes into the flame. The electrons then follow into the flame. They go around the ionized air of the flame to the ground, right? And that completes the circuit. So they're going around the ionized air of the flame. So if the flame's gone, it's an open circuit. So we want to see 2.6, roughly 5 microamps. Then we're up to 5 microamps DC for complete signal. Normally, if you have it, you're good. If there's no signal, it won't work. So that's called flame rectification.